Hello, this is Mrs. Ward, and I'm going to explain example 4 from section 5.7 optimization. So in this problem, we have a rectangular pole that has a 5-foot deck along 2 opposite sides and a 10-foot deck along 2 other sides. If the pole covers 270 square feet, find the minimum and maximum values for the dimensions of the pole and the deck. So the first thing I'm going to do is I'm going to label my little picture that I have here. So in this picture, I'm going to call let's say I call the top. Let's say this is 5 feet, and this is 5 feet down here. And then over here will be 10 feet, and this will be 10 feet. So that's the space of the decking around the pole. So if I call this X and I call this dimension Y, then when I go to find this whole thing up here, I'm going to have 10 plus the X of the pole plus the 10 on the other side. So that's going to end up equaling X plus 20. If I do the other way, this is 5. So I have like 5. Then I have the pole, which is a length of Y. And then I have another length, which is 5 again. So this is going to be plus. So this will be Y plus 10. So that's the dimensions. Now it tells me that the area of the pole covers 270 square feet. So that's just this pole. So the dimensions of X and Y. So X times Y is equal to 270. And then if I want to find the minimum dimensions needed for the pole and the deck combined. So that's going to be this X plus 20, Y plus 10, and that's going to be area. So the area of this entire thing is going to be X plus 20 times Y plus 10. And I want to do the minimum. So this, I'm looking for a minimum for this area formula. So I'm going to go back up here and I'm going to solve for one variable. Let's say I say Y is equal to 270 over X. Substituting that in for Y, I'm going to have my area formula is equal to X plus 20 times, in place of that Y, I'm going to write 270 divided by X plus 10. Now I have to find the derivative, so I'm going to choose to find the derivative. I'm probably going to FOIL it first because I think that would be easier. So if I FOIL this, I'm going to multiply my first term. So I'm going to multiply that X times the 270 over X and just get 270. Multiply the outer, and I'm going to get 10X. Multiply the inner, oopsie, forgot my X. Multiply the inner, and I'm going to get 540 1,000, forgot 0, over X. And then finally multiply my last, which would be 20 times 10, which would be 200. I'm going to go ahead and combine my like terms. So when I do that, I'm going to add the 270 to the 200. So I am going to say 470 plus 10x, and then I'm going to rewrite this as 5,400x to the negative 1. Now I'm going to go ahead and take the derivative so I can optimize this. Remember, I'm looking for a minimum. So the derivative of 470 is 0. The derivative of 10x will just be 10. Then I'm going to take the negative 1 times the 5,400 and get a negative 5,400. X reduces power by 1, so this will be raised to the negative 2 power. So that's my derivative. So now I'm going to try and find my critical numbers. So I'm going to first set this derivative equal to 0. And so when I set this derivative equal to 0, I'm going to have 0 is equal to 10 minus 5,400. And I'm going to go ahead and write this over x squared. I'm going to write it that way for now. I am going to add this to the other side. So I'm going to say 5,400 over x squared is equal to 10. Multiply both sides by x squared. So I'm going to have 5,400 is equal to 10x. Divide both sides squared. Divide both sides by 10. So I'm going to have x squared is equal to 540. And when I take the square root, that doesn't come out as a perfect square. So I'm going to round it. And I'm going to say x is equal to plus or minus, and I got 23.24. Remember, this is dimensions, so I'm going to ignore the negative. So I'm going to say my x is equal to 23.24. And I believe my units were feet. So this is going to be feet. So now that I know my x is 23.24 feet, I'm going to, oh, I have the other thing too. I have to find when my derivative is undefined. And since I have this in the denominator, that's going to happen when x squared is equal to 0. So x is equal to 0. Now, one's probably going to be a min, one's probably going to be a max. So I can either set up my table or I can find my second derivative. I'm just going to go ahead and find my second derivative. I think that's going to be easier. I'm going to switch colors to show you what I'm doing. So let's go to red. Going here where my first derivative is, I'm just going to find the second derivative. Find the second derivative, and the derivative of 10 would be 0. Negative 2 times negative, that would be positive. And when I multiply that by 2, I'm going to get 10800x to the negative 3. And I did that so that I can find my second derivative at that 23.24 feet. And I just want to know if it's positive or negative. And when I put that in, that's 108,000 over x to the third. And I believe that's going to be positive. So if it's positive, it's going to concave up. If it concaves up, that means that 23 point, this would have to be a minimum. So this 23.24 feet would be a minimum. Now that's my x. So that's my x would be here, the one that's with the 20. Now I have to find my y. So to find my y, I'm going to take 270 and divide it by that 23.24. And when I do that, I get, pause please, because I didn't do it yet. When I divide the 270 by 23, I get 11.62. So the dimensions on my pole would have to be 23.24 by 11.62 feet. And then this is feet. And that would give me the minimum dimensions needed for my deck and pole combined, so that my pole has an area of 240 square feet. Okay, I hope this helps, and I'll see you next time.